And welcome to the final video in our series on indices and surds. And in this final one we're going to be looking at division by surds, and specifically using a technique called rationalising the denominator, which might sound like a bit of a mouthful, but as you'll see shortly it'll make sense as to what that means. And then also we've got to be able to use difference of two squares to be able to do this when the denominator is in a certain form. So you should already have seen difference of two squares, definitely GCSE. You might have already been introduced to them again as part of your A-level studies, but if you're not sure what difference of two squares is, it would be well worth your while going back and having a look at that before you kind of launch into this section. So previously we looked at addition, multiplication, and division and subtraction, but the divisions we did were fairly straightforward. So what we're going to look at now is like more complex divisions using surds. And the reality is we're not actually physically going to do a divide. What we're going to do is just manipulate the denominator of a fraction to get around that whole issue of division, which is a technique or something that happens with division in a range of different circumstances. So what we're going to look to do is change the denominator from an irrational number or a surd into rational. Irrational numbers are basically decimals that just go on and on and on without any repetition, so square roots, but examples of them. Pi would be another very obvious example. And rational numbers are things like kind of fractions, whole numbers. They can be recurring decimals, or kind of decimals with repeating elements to them. But essentially, as far as we're concerned here, we just basically want to get rid of the square root on the bottom of a fraction. So let's have a look at how we're going to do this. So, three questions we're going to have a look at, each of them with slightly different issues. So the first one, what I'm going to do is take 18 over root 45. Now that root 45, we can simplify that a little bit first. So I'm going to write that as 3 root 5. And now in order to get rid of that root 5 on the bottom, what I'm going to do is just use a technique that you've been familiar with since primary school, which is just to do with equivalent fractions. And if you remember, the golden rule for finding an equivalent fraction is whatever you do the top, you do to the bottom as well. So what I'm going to do is times the top and bottom of that fraction by root 5. So we're doing the same to top and bottom. And if you consider it, what's going on here is that this element here, this root 5 over root 5, that's just got a numerical value of 1. So all I'm doing is taking my fraction, timesing it by 1, and getting a new fraction with different numbers that's going to be numerically exactly the same size as we had before. That's how equivalent fractions work. So we'll do the multiplication. On the top I'm going to get 18 root 5, and the nice thing is on the bottom, that root 5 there is going to multiply by that one. Root 5 times root 5, as we now know, is just going to be 5. So what we end up with is 18 root 5 on the top and 3 times 5 on the bottom. I'm not concerned about the fact that I've ended up with a square root or a surd on the top. The key to this is making sure that we do not have one on the bottom. That's why we're rationalising the denominator. That's why it's called that. All that's left to be done now is just a little bit of tidying up. So 18 over 3 is 6, and we end up with our answer 6 root 5 over 5, or you could describe that as being 1.2 lots of root 5. I personally prefer to use fractions. Okay, so what we've got there is a simple example. Rationalise the denominator, getting rid of the square root on the bottom. On to example B. Now, this time we've got a bit more work to do, because just multiplying top and bottom by root 3 isn't going to work, because if we did that, we'd have to times the bottom by root 3 there. We'd also have to times it by 5, so we'd end up with a 5 root 3 on the bottom, and the square roots or the surds wouldn't disappear. So we need to be a little bit more creative, and the way to do that is to use difference of two squares. So there we go. But what I'm going to do, notice that absolutely the key element to this is, get my cursor, I've got a minus there. I want to make sure that that one is a plus there. So that sign there is the opposite of that one there. Now, some of you might have already spotted what's going to happen, but if you haven't, don't worry, all will become clear when we go through the next step. The other thing to note at this time is I'm not at all interested in what's going to happen on the top. We're going to end up with something completely different. That's not a problem. It's the bottom I'm interested in, and I've got to make sure that my square roots disappear on the bottom, which is why I've picked 5 plus root 3 there. So do the multiplying out. So on the top, there's effectively our 4 terms for multiplying out the bracket, and on the bottom there's our 4 terms. And here comes the sneaky bit. You can see at the moment we've still got square roots, but you'll notice I've got a plus 5 root 3 here, I've got a minus 5 root 3 here, and that's coming as a result of the different signs in the two brackets here. So what that means is that one will cancel out against that one. The square root bits disappear. I'm just left with whole numbers. So I'm going to be just left. You know, I can't find my cursor. There we go. We're just going to be left with the 25 minus 3. So tidying up on the top, I've got 15 plus 3. That's going to be 18 plus 8 lots of root 3 on the top. And on the bottom, I've simply got 22. So the square roots, because of that difference to two squares, because the middle terms disappear, the square roots have disappeared, and I've ended up with 22 on the bottom. And we can just divide top and bottom by 2 now, just a little bit of simplifying. And there is our simplified answer, 9 plus 4 root 3 over 11. And you'll notice clearly we have rationalised the denominator. There is no longer a square root in it. Cool. On we go. Our next example. And what we're going to do before we kind of do the rationalising here is just have a little bit of playing over on the right side of the page, just figure out what we're going to get on the bottom. I've got 1 plus root 5 all squared, so that's 1 plus root 5 times by 1 plus root 5. Work out what that is. That's going to give me 6 plus 2 root 5. Now I'm set up and ready to go with my calculation. So here we go. So first step, I'm going to replace 1 plus root 5 all squared with what I know it's equivalent to, which is that 6 plus 2 root 5. I've now got to choose my fraction to multiply by, and I know I'm going to choose this fraction here, 6 plus 2 root 5, but I'm going to change that plus side there, and I'm going to change that into a minus. So I'm multiplying by 6 minus 2 root 5, top and bottom. Do the multiplying out, and notice we've just got to be a little bit careful with signs. I've just kind of put that exclamation mark there, just make sure that we're aware that we've got a minus 3 root 5 and minus 2 root 5, so that becomes a plus, minus times a minus. And on the bottom, there's my 4 terms, and again we're going to notice that the terms in the middle, minus 12 root 5 plus 12 root 5, they're going to disappear, and so I'm left with that. And again, we've just got a little bit of simplifying to do, and again you've got some choice on how to do it. I've looked at this and gone, well, you know what, I've got 32 and 16, that's going to be 2, so let's just deal with that and do it that way. So I end up with 9 over 2 minus 2 root 5. Okay, there's another couple of ways in which we could describe that, but for me, that's probably about the simplest. Job done. Okay, so in both cases, what we've done is got rid of the square root on the bottom and ended up with our value in terms of a rational number there and an irrational part there. Okay. Finally, an example of the kind of thing that you might expect to have to do when it comes to an exam. So we've got to do a bit of addition on the top first, and then follow that up with a division or a rationalising denominator on the bottom. And we're told very clearly the format we need to get it in. We've got to get this whole thing in terms of root 2, and we've got B and C have got to be integers. They're going to have to be whole numbers. So to deal with this one, first thing I'm going to do is deal with the addition on the top and have a think about that first before I start doing the rationalising. So I've got root 32 and root 18, and we saw in a previous video the way to go about that is just to express them both in terms of the same square root, and we're given a clue in the question. We're told we need it in terms of root 2, so let's take both of those and write them in terms of root 2. There they are. So those two things added together are going to give me 7 root 2. So now my division sum becomes 7 root 2 over 3 plus root 2. Now I've got to rationalise the denominator. I know I'm looking at a plus there, so the thing I'm going to multiply is going to be 3 minus root 2. There it is. So on the top I've got 7 root 2 times 3, so I'm going to get 21 root 2 there, and I've got 7 times by minus root 2 there. So there's 21 root 2 minus 14. And on the bottom, we've got 9 minus root 2. Notice this time I haven't included those middle terms, and as you get better at these and more comfortable, you're able just to kind of jump straight to that step. Let's just have a think. The 9 is coming from 3 times 3. I know the middle terms, 3 minus root 2. Root 2 times 3 are going to disappear, so that just leaves me with the root 2 times root 2, positive times a negative, so we've got a minus, and root 2 times root 2 is 2. If you're not that confident with it, then by all means just write them all out and then just cancel off the middle ones, but if you're feeling a bit more comfortable, you can just jump straight to that. And so now we can see we've got 21 root 2 minus 14 over 7, and hopefully now you can see those are all going to cancel out against each other. we can see we're going to end up with this expression here that we've got integers, we haven't got fractions, and clearly divide by 7, we've got 3 root 2 minus 2, which is in the format that we're after.